So my name is Luca. I'm VP of Architecture at DAZN. I'm a Google developer expert on web technologies, and finally, I'm the manager of the London JavaScript community. So if you are looking for a community and some talks at JavaScript, check it out on meetup.com. Okay, so I think everyone in this room, at least once, has the possibility or has, let's say, approach an architecture in the way that you can see in this slide. So imagine that you have like a new greenfield project or you're working for a startup. The first thing that you want to check is validating your business idea. You really want to make sure that your ideas start to fly. And that means that sometimes you need to make some trade-offs on the technology stack. Because that's the reality. Architecture is not creating the best architecture ever, but it's creating the one that could make your company successful. So, and that includes trade-offs. So one thing that you can see here is usually what you have is trying to work with monolith, because when you are trying to get something out to your audience, you try to figure out what is the best way to do that. And a monolith is absolutely something that you need to take in consideration. A single page application is not deprecated. A monolith layer with an application server is not deprecated at all. A quick way that you can gather information for the final user. Remember that each line of code that you're writing nowadays is not for you, and maybe it's also for some people in your team and your organization, but the reality is you are generating code for your users and you need to create value for them. That is the key thing. And in this architecture, there's nothing wrong. It perfectly fits in a specific moment of your moment of life cycle inside your company. So here you have an application server and maybe a database, could be SQL, NoSQL, whatever. So let's assume that suddenly your business ideas start to fly and start to have traction, and you have like people that are subscribing to your services, or they are starting to use your application more and more. So then the company usually starts to say, okay, perfect, it's successful, we have a bit of money that we can use, so let's start to reinvest on the idea, and they start to augment the development team, they start to augment to increase the company, and it's becoming, let's say, more complicated having everything just with this stack. And usually it's where microservices are coming in this case. So you start to say, okay, perfect. On the back end, I see that there is the critical path of my architecture that maybe requires to scale differently than another service that can be highly cached behind the CDN. Hey, happy days. Then what I can see is that the developers on the back end, they can start to pick the right programming language and the right database for the job. There isn't any more one-size-fits-all model where you have in the monolith, but you start to say, I want to use the right approach for a specific thing, and that makes a lot of sense. But what about front-end? In reality, in my experience, what I've seen in front-end is that you start with a single-page application, you continue with the single-page application till it's, let's say, so complex that you start to rewrite, but it's a monumental chunk of work that you need to rewrite because maybe it's running for several years. And what about the developer experience? Developer experience, usually there are a bunch of guys that start this application. Maybe they are still in the company, maybe they are not anymore, but the reality is they are taking certain decisions that you have to live with them forever and ever. Otherwise, it will require a tremendous amount of work in order to change certain decisions. That maybe you can do that, but sometimes you cannot. So I was in this situation when my company started to scale, and I have to figure out if on the back end I had a way to manage the complexity and the fact that we were blitz scaling. On the front end, I didn't have an answer to say, okay, how I can make this single page application scalable to multiple teams in distributed offices, and maybe having also people that are working remotely. And after a while, what I come up with was the possibility to take this single page application and divide that in micro-frontends. And that's basically why today I'm talking about them. So let's take a step further. Let's try to figure out how we would define micro-frontends. Currently on the web, there aren't too many definitions. So this is the definition that I came up with, and I think it provides a decent understanding of what they are. So for me, micro-frontends are a representation of a business subdomain. This is coming from domain-driven design. I'm pretty sure that quite a few of you are familiar with that. They allow independent implementation. They can share the technology or can have different technologies. And they should avoid sharing logic, and they are owned by a single team. The ownership part is very, very important, because if you don't have a strong governance, you risk, honestly, to not have a project that could work properly, not because of an architectural issue, but more due to a governance issue. So that is something very, very important to think about. But technically speaking, what it is. So for me, currently, imagine that you have this single page application that contains like different business logic and different domains. It could be either an authentication domain that is composed by the sign in and sign up. It could be the core domain that is the catalog here, and so on and so forth. And then we take those domains and we start to split them. How we split them, it's very important that, in my opinion, we look at the value that we can provide to the user and not the value that we provide to the developers. So what it means is, in domain-driven design, one of the things that you usually do, apart from defining the ubiquitous language, is also identifying some subdomains. And working with subdomains could work also on the front end. I don't understand why for so long we always kept the domain-driven design away from the front end, where it's part of the domain as well. Why not? So that is, for me, the key thing for understanding micro-frontends. So when I started this journey, the problem I had is, how can I scale a single-page application with hundreds of developers distributed in Europe? And unfortunately, I didn't have an answer. So what I thought is, okay, let's start to look at a successful architecture pattern that allows me to do that. And obviously, microservices was the first one that came in my mind. But at the same time, I cannot apply the same technicalities that you can find in microservices. So I took a step back and I looked at the principles. So first principle is model around business domain. Yes, I can do that on front end as well, because in particular, if I have an existing application, I can see how my users are interacting with my application. I can understand how how they are behaving inside the application. I can understand what are the flows that are following, what are the funnel that they're following, what is the most used payment method, what is the way how they're interacting with a specific carousel and so on. So that is something that I can do. And also, business domain, it means also that I can speak internally with my product team and trying to figure out how I can create something that is frictionless, not only for the users, but also for the internal communication that you have inside the company. Then the other thing is the concept of decentralization. So if up to now, we always work with architects and tech leads that were basically defining the best practices. Now I think we are heading towards a new way to work with the teams, where we create guardrails, and inside these guardrails, they can take their own decisions. It's very, very important that who is close to the business domains can take the best decision for the business domain. That is, it is honestly, in particular in large organizations, it's impossible to know everything about any domain. It's really impossible. So you need to trust your developers that are closer to the action. They live and breathe on the specific domain. The other thing is a culture of automation. It's like in microservices, to a certain extent, writing the business logic on microservices is pretty easy. There is no rocket science there, right? On micro-frontends, potentially the same. The thing is, if you don't have a strong automation pipeline that allows you to generate a feedback loop for your developers that is quick and can deploy quickly in production, learn from your users, then you could blame the architecture, but the reality is the automation that you need to look at. Deploy independently. One thing that for me is important to stress is the fact that when we work with microservices, ideally, one thing that we want is deploy independent microservice. At the same time, on micro-frontends, I want to do the same. I don't want to, every time that I make a change, deploy 2, 3, 4, 45 micro-frontends at the same time, because that will be a failure, because that is basically distributing the complexity across multiple teams. And if you have teams that are not even co-located, good luck. Then we have hide implementation details. So another thing is you need to work with API contract. It's very, very important when you manage that, because if you start to have some APIs that are tightly coupled between different bounded contexts, you risk to have a lot of complexity that you need to manage. So you really need to do a huge work on defining APIs that allows you to communicate between micro-frontends if needed, as well as with components. And we will see in a moment how. Then we need to isolate the failure. We have a new dimension on the front end. This is before we have a single page application or a server-side rendering one where we download the entire application. We have everything there, all the code is there, and you just jump from one view to another one, no problem at all. Here we start to have a different dimension where part of the application could fail due to network condition, or someone is looking at your application with a mobile device and it lost the connection, and so on and so forth. So there are new things that we need to think what could go wrong and how I mitigate that. The important thing is not thinking, oh, I need to prevent that something goes wrong. The important thing is understanding how you can mitigate that failure, because that is the important thing, without affecting the entire application, obviously. Okay, so when I was in this journey then, I was doing a workshop in Norway, and I was talking about this thing, and suddenly I have a sparkle in my brain. I started to say, I was talking literally, I couldn't stop because obviously I was in the middle of the presentation, and I had this idea of 4 key things that, in my opinion, when you nail those four key decisions, it will cascade all the other decisions inside your micro-frontend architecture without any problem. So let's see them. So I think there are those 4 decisions. So define what is a micro-frontend, compose a micro-frontend, so how do you compose them, how you route micro-frontends, and how you communicate micro-frontends. Those 4 decisions, that we will see the options in a moment, will allow you then to take all the other decisions, like how I manage my design system, or how do I create my design system, how I'm going to share the code between micro-frontends and stuff like that. Because those 4 decisions are the key ones that define your architecture. I define them as decisions framework, because I think this is very powerful, but these 4 will allow you to, let's say, define your architecture, and then you can move along without any problem. So the first one is how you want to define a micro-frontend. So there are people that are defining I have multiple micro-frontends inside the same view. So they represent basically a micro-frontend as a part of the view. And that is not wrong. Is one of the options. There are strong use cases for this approach. For instance, SAP is they release a framework called Luigi framework. And what they do is having iframes that are coordinating that. There are other options that you can do a composition, and then we will see in a moment on the server side, but the reality is you will have multiple micro-frontends inside the same view. That it creates some complexities. How do they communicate together? How I manage the dependency and the dependency clash between those. So there are some challenges there, but you need to ask a few questions around this. The other thing is thinking about slicing them vertically. So I represent a micro-frontend as a single HTML page or a single page application. Those are the 2 options that you have currently available. And those are going to drive all the other decisions. So when you decide if you want to go, hang on, there is another more thing. So on the horizontal split, so when to use them. On the horizontal one, there is few things that you need to take into consideration. You have an upfront investment on creating a smooth experience for testing everything. Because if I test in isolation one part of the view, how I make sure that this part is not clashing with the rest of the view? And therefore, you need to figure out what is the best way to do that. New Relic, for instance, invested on the developer experience heavily on that part, and they started to do talks on explaining how they work, but basically they have an app shell that is containing some templates, and they load micro-frontends inside these templates. The thing is, they didn't go very granular, so they have like a fairly simple template system. So you have 2 or 3 micro-frontends at the same time, but that is an investment that you need to think about. In the case of New Relic, it makes sense because they have dashboards that are self-contained, but if you have like elements that has to jump from one side of the screen to another one, and you have strong animation and a lot of interaction, then it could be complicated to manage that. Then you have to think about the team structure, how your teams are structured in the horizontal thing, because if there is a team that is owning, let's assume, let's say a carousel inside your application, then okay, so that team is owning that, develop this, and then what other elements is going to use, because you need to figure out how you assign tasks and micro-frontends to each single team. It's it's a great thing for SEO. So if SEO is one thing, you can do server-side rendering and compose everything on the server side, and then you serve that to the crawlers. There are other options you can do also for vertical split, we'll see in a moment, but that is a good thing that you can do. There are testing challenges. Because if I test in isolation my micro-frontend in this case, then how can I test end-to-end everything? Who is owning the end-to-end test? Is it there is a team that is owning the final look and feel of the page? How I can create a smoothless experience for our users? There are scalability challenges. So if I'm working on assembling those micro-frontends at runtime, and I have a lot of personalization in my page, so I need to think twice when I start to assemble that on the server, because if I have a spike of traffic at some point, I need to scale horizontally that layer. Is it something that is doable? What kind of complexity is bringing inside my organization? So those kind of questions you need to think about. Finally, the dependency management, because if you have an iframe that is at the end a sandbox where you can throw inside there wherever dependency you want, the moment that you don't have that and you have to assemble, you have also to think the final bundle size. You have to think about how you can manage, if you can manage to have different versions of the same framework, or you need to coordinate certain things. So those are a few questions that you need to answer before you decide to go with the horizontal one. For the vertical one, though, is easier. We have a more traditional development, because if you think about that, as I said before, it's just having an HTML page or a single page application. That is basically what we are doing in front-end in the last, I don't know, 5-10 years. The other thing is you don't create solution custom for your business. You use the solutions that are out there. So if you can use Webpack in the way as it is, you can use Rollup, you can use whatever you want, whatever tool is out there, you can still embrace. And despite that is currently available or it will be in the future, you can just embrace because it's normal development for your front-end developers. Finally, for mitigating the problem of SEO, you can use dynamic rendering. So Google released last May the possibility to provide and serve to the crawler a specific version of your page that basically is optimized heavily for indexing the content. It's something that I encourage you to check on the Google website. If you search for dynamic rendering, it's pretty powerful, and for instance, we are using heavily on our application. Second step is how I compose the micro-frontend. So I have basically three options here. One is composition on the client side. In the case of this approach, you have an app shell that is always available inside your application, and you start to load different micro-frontends in the same view, or you load just one single page application, for instance. In this case, usually you have all your the micro-frontends on origin. That could be either an application server, or it could be a simple like an S3 bucket. And you have a CDN that is may or may not be there, but I would recommend to have that. And the CDN basically is serving the content instead of going every time to origin. So that is definitely a good option. The second option to compose micro-frontends is using what is called edge side include. That is a markup language that is proposed by Akamai and is implemented in several CDN. And basically at the CDN layer, they fetch all the different pieces of micro-frontends, and they put everything together in a unique page. So for the user, it's like downloading a single application. It fades out completely out of your hands. The possibility to scale that part because it's taken care by the CDN, great stuff. So if you have static pages, great for that. It's becoming more complicating as a developer experience though, because as you can imagine, testing on the CDN means that you have always to try over there. The other thing is you need to pay attention, because if you decide to go with Akamai, hey, happy days, everything, the entire edge side include spec is there. But when you move to another CDN, you don't have all the APIs available. Therefore, certain things you can do on Akamai, you cannot do on other places, or you cannot do at all, because there are some CDN that are not allowing you to do that. Finally, you can compose at origin. So, for instance, a famous one is Zalando. Zalando, this fashion e-commerce, allows you to compose everything with they had before Mosaic 9, that is an open source project, with Tailor.js that was basically taking different HTML fragments and compose everything together. Now they moved away from that and they decide to go with React and GraphQL, always with the same approach. So like they compose at the server-side level, and then they serve through a CDN. There is other options like OpenTable and Skyscanner are using open components. It's another framework that allows you to compose everything at the origin and then serve at the CDN, because they have, let's say, less the data that are personalized to a certain extent compared to other approaches. So those are the three ways that you can compose. After that, you decide if you want to go horizontal or vertical. So the first step is, okay, how do I decide to go with the first implementation? So I compose at the client side. So how can I move from one micro-frontend to another one, to one view to another one? So in that case, you have two options. One is doing at the CDN level, like using Lambda at the edge, or if you use like CloudFront, you can also instruct CloudFront to load different parts of the application from different places. The other one is routing on the client side. So in the app shell, basically you have the macro routing, as I call it, where in the macro routing you just say, okay, I have those views, and then it could be either that you load an HTML page or on a JavaScript file. It depends how you structure your application, but that is another option. Then you have the edge side include with CDN. What you can do instead is the only way is routing on the CDN level, because obviously all the logic is happening there. So you basically hit a URL, and the CDN is just saying, okay, so now I assemble these components together and I serve the page. So that is the way how you route. And then at the server side, in that case, you can, let's say, do also on the client in this case. But my suggestion would be do on the origin, because you have all the application logic that is running there. You are assembling your pages there, so you can do, let's say, quite a lot of logic also for the routing bit of micro-frontends. The last bit is how do they communicate together. So if I have a horizontal split, I can have something like that where I need to decide how, I don't know, one component is communicating with another one. So the challenge here is that you need to find a way to not couple them. So there are two options here. Or you have an event emitter that is owned by the parent that is containing everything and injecting inside each single micro-frontend, or you use custom events. Custom events are a standard in JavaScript, so you can use that. You're just bubbling up events, and everyone is listening to them. That is the two options that you have. Then there is another thing, that how I can communicate from one view to another one in order to pass data across that. So there we have two options. Again, we can use web storage. So you have, for instance, imagine that I have the authentication part and the user is signing in, and then a micro-frontend receives the JWT token. It can store inside the web storage, local storage, for instance, and then when the authenticated part is loaded, it can fetch the JWT token from the web storage and double check if the user is entitled to watch that part or whatever. But the communication here could be either from web storage or through normal query strings. So I can pass some data that maybe are not sensitive, possibly, on the query string, and picked up on another micro-frontend, and then do a query, or consuming an API with that specific ID or that specific information that I use in query string towards my APIs. So those are the four things. In all of that, there is no right or wrong. The context here is driving those decisions. So it's very, very important that one thing that is very important to highlight is not the technical context only. It's also how you structure your company, how you're going to grow inside your company, how you want to manage certain communication. Because the complexity of scaling a front-end application is not on the technical side. Here we are not talking about vertical versus horizontal scaling, stuff like that. It's the communication overhead, how you manage different teams, how you don't create external dependencies. Those are the killer for scaling front-end teams. So bear in mind this when you pick one of those decisions. So now let's try to figure out how, let's say, directly from the trenches, some experience. So I work for this company. It's called DAZN. If you don't know that, we are like an OTT platform similar to Netflix, but for sports. We mainly do live sports, but we have also video on demand. We are currently available in 9 countries. We announced yesterday that we are going to be available in 200 by this spring. So it would be quite exciting time right now in being in the zone. But the complexity we have on the front end is quite unusual. We don't have only the web and mobile, but we have also quite a few TV targets. We have Fire TV, Android TV, DAZN, Sony CB, and many others. So we have a lot of clients that we have to serve. And Micro-Frontends is helping to improve the experience for our users. So let's see what is a micro-frontend for us. So technically speaking, a micro-frontend is this, the holy trinity of JavaScript. HTML, JavaScript, CSS. It's pretty simple. It's how a single page application is composed. It's nothing different from what you do nowadays. And that for us was very, very important because we didn't want to create something that was dedicated only to the zone, and every time that we have a new joiner, they have to learn how to do their job. They know perfectly how to do their job. The thing is, we need to find a way that we can use the holy trinity of front-end for doing micro-frontends. So the artifacts that we have, that we serve, are exactly this, as you can see. Now we need something that orchestrates everything. And for us, the decision was we go client-side. Also because TVs is quite complicated sometimes. So in this case, what we have done is creating what we call the bootstrap, that nothing has to do with the framework, the CSS framework, nothing has to do with that. It's just the first thing that we load when you type DAZN.com, we load the bootstrap, and it's basically a simple HTML page that contains some logic for loading micro-frontends. So what it does is this. So first thing that it does, you type DAZN.com, and you have the bootstrap there. It's loading the application startup that is retrieving the configuration, so it knows in which device you are using, it knows which country you are, and feature flags and other information. It abstracts the input-output operation mainly for TV. We cannot rely to the web storage on TVs because not all of them allows us to work with that. So we decided to abstract that part. So you always, if you want to store a JWT token, you always pass through the Bootstrap APIs. It provides also it triggers some callbacks on some life cycle. So the micro-frontend knows when it's finished to be mounted and when it's going to be unmount. Those are the two things that we have to notify to the micro-frontend. In particular, for the unmount part is important because they have to remove all the listener and anything else that is in memory, because we are going to wipe out all the dependency the micro-frontend has. And finally is taking care about the communication between micro-frontends. For us, the decision was going to the local storage. So every time that someone wants to store something, it's communicating through the Bootstrap APIs and store everything to the local storage. That is the decision that we made. After that, we define a few other things on our micro-frontends. Those are some principles that we have internally. So each micro-frontend represents a business domain. For instance, one business domain is for us the discovery part. Discovery means the catalog with the video player and so on. So that part is a business domain. We have our, let's say, product team. We have multiple teams that some of them are working on TV, some of them are working on web. Some of them are working on mobile, but the logic is we have that domain that is mapped with teams. A micro-frontend is autonomous, so it doesn't have. So if I want to release discovery, I don't have to ask permission to anyone. I just deliver that. Each team is responsible for that, and they build it, and they own it, and they deploy it. We always load inside the Bootstrap one micro-frontend per time. So for us, that was very, very important to create something that was easy to understand and debug. When we started to look at the complexity that we are dealing, having multiple micro-frontends in the same view led us to build a lot, in particular because we are a large organization working on something very complex. And instead, if we're working in a vertical way, so we create like some single-page applications, it became very natural to manage everything because it's all the JavaScript developers always work in that way. There is no sharing between micro-frontends with some caveats. So for instance, we have recently we introduced the first shell library, that is the payment shell library, and there is a good reason why we did that. Because if we have a new SDK for the credit card, we cannot afford to have one micro-frontend that has the latest SDK of the credit card and the other one it doesn't, because otherwise it could blow up the payment. So in that we force the coupling between two micro-frontends, that is having this shared library where we have all the payment methods and are used and consumed by two micro-frontends. So every time that we change the shared library, those two micro-frontends has to update simultaneously and deploy simultaneously. That's the only dependency we have. We duplicate certain parts. Like, for instance, the header and the footer are duplicated in each single micro-frontend. We are not, let's say, abstracting that because the abstraction could lead to coupling, and we don't want coupling. The other thing that was important is being technology agnostic. So each micro-frontend can take their own path. Funny enough, when we proposed that, we found that the teams wanted to follow what the first team was doing. So at the end, we end up with React and, React and MobX. Okay, so how it works. So when we load the web application, the first thing is called startup service, consume the API, retrieve a JSON with a lot of information. Then the Bootstrap understands the user status. So it understands if you have a JWT token stored in the local storage or not. And if there is validated that you are entitled, is still valid your JWT token. When it does that, and let's assume that you are entitled, we load the HTML. And how we load that, the logic was, okay, we can start having as entry point a JavaScript file. Like there is a famous framework, single SPA, that is starting from that assumption. But for us, it wasn't enough, because we wanted to do server-side rendering at compile time. So we want to provide the user the best experience possible, and we don't want to wait that all the JavaScript is loaded, parsed, and being available to the engine. So what we have done is creating an HTML page that is server-side render if the team feels that is needed, and provide the skeleton of the page, and then slowly but steady loading everything. So HTML at the end is an XML file with a specific schema. So we basically have this entry point is an HTML. The Bootstrap is loading this HTML and appending inside itself the DOM elements that are needed in order to compose the page. When arrived to the script and CSS, the browser automatically will load vendor, application, and CSS. So as you can see here, we didn't invent something, let's say, that is not available. It's already there. We just use what is a standard. So this is an example. So I did a screen recording of this. So please keep an eye on the flashing inside the DevTools. Oh, sorry. So as you can see, there are quite a few flashing. So the loading was in the Bootstrap. Now I obviously throttling the speed of my connection. And slowly but steady, we arrive to have the application. And again, my main aim here was showing that basically we're not doing anything custom that we created on ourselves. It's literally, I parse an HTML, I append the DOM nodes inside the Bootstrap, done. There isn't a specific framework that we're using. There isn't anything. It's vanilla JavaScript, and that's it. So how we route our application. So there are a few things that we were thinking. So first of all, our infrastructure is really, really simple. We didn't want to do anything smart because when there is, in our one situation that we have to deal often on the back end is, imagine that you have a Champions League final and you have like all the people 5 minutes before the kickoff that are joining the platform. So you have like millions of users literally that are hitting your platform heavily. And if we have smartness on composing everything on the server side, it could be complicated because you have to take care about a new layer to compose everything. So in this case, we went with a very basic thing, so CloudFront and S3. So we basically generated and do everything at compile time, and then we store our artifacts on S3, and CloudFront is our CDN. CloudFront has another thing that is pretty cool, that is Lambda at the edge. Basically, it's running some lambdas in the closest edge node that CloudFront has. And the beauty of this is it can add some logic. So for instance, for us, this allowed us to do canary releases. So we can say, if you are in Canada and you're using Internet Explorer, we serve the old version of the application. But if you're using Chrome, 20% of the traffic goes to the new version. And that is very simple because you can do also in other ways. We decided to go with the Lambda at the edge because it's providing also quite a lot of flexibility for us. And overall is a fairly cheap strategy for doing that, because you are basically abstracting all the problem of canary. So the client is like the same way that is 100% or 20%, whatever it is. So you are completely, the client is completely unaware of what's happening. It's just being served or not to a specific client. Then the Lambda at the edge is loading the bootstrap, and the bootstrap is loading the micro-frontend. It could be the authenticated one, not authenticated. It could be deep link, whatever it is. But those are, let's say, the layer that we have. And again, because everything is cache, is very quick also as a response. The last bit is, obviously, we don't have only micro-frontends that are vertical. We have also components. One classic example for us is the video player. Having a video player optimized for live, I can guarantee you is very complex, because it's not the same I take Shaka player and I squeeze in my page, done. Unfortunately, all those video players are optimized for, obviously, VOD, and we had to change the heuristics. So we have a team that for each single video player of each single device, if possible, is creating new heuristics that allows us to have the best performances for live and provide the best experience for our users. And obviously it's a very, very complex thing, because not many have done that before. So we have a team pretty big at the moment that are working just on the video player. So the video player for us is a component, and this is not loaded at runtime or anything. It's treated like you load any other components. So you just import your components. So the team that is working on the video player is basically creating a package on the private NPM, and is picked by any micro-frontend that is needed, and is just importing this video player. And again, this is another way that you need to identify inside your micro-frontend some areas that could be complex, video player, or the payment API, and understand when you want to abstract them. But vast majority of the time is just a simple team that is working, of 5 people, that is working on a micro-frontend, only on the front-end side, not back-end, and are working on the entire user experience for that micro-frontend. So what we have learned so far, so what are the takeaways for this journey? So the first thing is that we understand that first we need to identify our micro-frontends, so how we want to build them. We want to compose them. We want to orchestrate them. That is another interesting bit. And we want to understand how they communicate together. Those 4 actions are critical for, and are your 4 pillars for creating a successful micro-frontends architecture. Then there are other things that we didn't discuss today, but are there, right? So automation, you need to invest time. That is a nice investment. I saw too often project failing just because the automation wasn't there, and you need to, it works on my laptop, but God knows why not in production. So that is very, very important. So do that investment upfront. Observability, obviously, more micro-frontends and more distributed part that could fail. You need to understand why they're failing, when they're failing, potentially be proactive more than reactive. So tools like LogRockets, Sentry are definitely useful for you. How do I integrate? How I can create a consistency of the user experience inside my micro-frontends? That's another thing. So for us, for instance, we started with providing JSON to different teams. And now we are thinking to have a proper design system with some components that are not too complicated. We are not going to have, like, I don't know, header or footer or stuff like that. We are going to have a button, a link, or something that is very, very dumb, because then each single team can implement and compose their stuff by their own. Team's impact. That is another important thing. When you design anything, when you take any decision, please don't take only the technical part, but think about the impact of your decision inside your organization. It's very, very important that you think about that, in particular when you work with large teams, because your decisions will affect the communication between teams and how they're going to succeed or not. So it's very, very important, that part. How you manage the dependencies. That's another thing that we briefly touch. So how, if I have an horizontal split, how I'm going to put everything together, and how I avoid to have clashes around that. Duplication over abstraction. One thing that I used to say is the wrong abstraction is way more expensive than good duplication. As something that I know that, let's say in several books, we are saying, oh, don't repeat yourself and all the other things. The reality of the things is I totally agree with that. I'm not here standing in front of hundreds of people saying, no, please duplicate, but try to ask a couple of questions before you immediately decide, okay, let's abstract that, let's have an external library, because that will lead to some complexity. If you have distributed teams with a core team that is in a completely different country, then you have external dependencies to manage that are way more horrifying for developers than having some duplication. Finally, performances. I heard on several socials that with Micro-Frontends you cannot have performances. It's not true. Everything that you know already on how to optimize your application is totally applicable on Micro-Frontends. So you can have performances, you can have the less than 4 seconds load like Google is suggesting on mobile and web without any problem. The only thing is you need to be smart in the way how you are taking a certain decision. Obviously, this is just the beginning. Micro-Frontends are not what I call a silver bullet. I'm not saying from now on, when you get out from this room, you all work with Micro-Frontends. Absolutely, single-page applications, server-side rendering are still and will remain a valid option. But finally, we have a third option on top of that that will allow us to deal with certain problems when we operate at scale. Before it was, we need to figure out a way to manage that, and we saw several options for doing that. Obviously, Micro-Frontends are not going to solve all the problems of the front-end world. Are just an approach that in certain contexts and applied in a certain way could make a lot of sense. Obviously, this journey is still under discovery. Micro-Frontends is not, let's say, a super consolidated architecture. So what I'm trying to do is, with these talks, just to create the interest, and then there are tons of other resources you can find. So here you can find on the left a link to a page where I collected all the articles, all the things that I have done so far on Micro-Frontends. Next week on Tuesday, I have 3.5 hours webinar on O'Reilly. If you are interested, there is still space. And basically, I'm going to deep dive in each single part that we have seen today, including the impact on the teams. Last but not least, last week, I'm writing this book for O'Reilly, and is in early release. If you have access to Safari Books Online, you can read the first 3 chapters, and feel free to provide feedback. That's really it for me. I hope that you enjoyed the talk and enjoy the rest of the QCon.
So we have about 8 minutes. Questions?
Hi, thank you very much. It was a very interesting talk. One question. When you started, you said that you tried to split your front end following domain areas. And you said that because of the backend was already doing that, and they had already microservices, and maybe organized their microservices around domain areas, you are trying to do kind of like the same in the front end. In your experience, do you find that there is any alignment between the domain areas in the front end and in the back end? And if you do, how do you align the teams? Do you have one team with shared resources, front end and back end, or you have 2 parallel teams? Thank you.
That's a great question. So what we have done is first identifying the 3 types of domains that we have. So generic, supporting, and core. Those are the 3 DDD domains that you can find. Then we mapped inside the application, in a context map, what are the different areas. And we did a step further. So we reorganized the company in having, in each dev center, we have currently 4 dev center, specific domains. So for instance, if you go to Amsterdam, you have the entire acquisition retention that for us is a generic domain, and we have the front end for web and for TV. We have all the backend for all the payment, subscription management, and everything that is inside that building. If you go in London, you have what we call the core domain. So you have the playback, you have the discovery part, and the catalog, metadata, and so on. So we try really not only to focus on, okay, we identify the technical part, but we try to understand, and that's why I was stressing during my presentation, how the communication between teams could work. Because at the beginning, when we started this journey, we said, okay, so we can have like a bit of sign in, sign up in London, a bit of discovery in Amsterdam, but we saw, before even starting this discussion, that something was clashing. And this approach provides, let's say, a lot of flexibility, but you need to a certain extent, understand what is the social impact inside your organization with this.
So you mentioned when you were talking about duplication over abstraction that things like the footer are duplicated.
Yes.
How do you handle when you need to make a change to that across your whole application?
Okay, that's a usual question that I receive after this talk. So in this case, we have these two things, so footer and header, that are duplicated in 5 different micro-frontends. So when I decided to do that, I was thinking, okay, so let's see in Git in the last 3 years how often we change. We changed 2 times. So we had to change again the 3rd times when we implemented this micro-frontends thing. It was 5 tickets created in Jira and roughly a turnaround of 5 minutes per team. So obviously, I'm not saying duplicate everything because that is not my aim, but be wise. That's why I'm saying ask yourself some questions before you start to say go with an abstraction. Because if I try to replay, if I decided at that time saying, okay, let's go with the share library, let's say a share library that I include footer and other stuff. Then the question started to be, okay, now I have like teams distributed around Europe. So one team maybe has a specific request. The other team doesn't have the context, doesn't have why they have to do certain things. And then they do that, and maybe they create some bugs. And then in order to test, it becomes a nightmare because the ownership is let's say, in different places. It's true, I have to write 5 times, but let's say is way less error prone than having, in this case, a component library that contains 2 things that are changed 3 times in 5 years.
Hi, a question related to sharing the libraries from Bootstrap to the components. So as you said that the first team went with React and Mobex and the subsequent teams follow the trend. So in your opinion, would it be wise to share the React version from the Bootstrap to the components? Or
yeah, there are, for instance, if you use a single SPA, that is a framework that is working with vertical split and as entry point JavaScript. You have the option to do that. Last week there was a release by, so there was a new plugin of Webpack 5 that basically allows you to define, lazy load different parts of the application, so different micro-frontends, and share the dependencies. So there is definitely a trend around that. We didn't took that thing, but if you go ahead a step and say, okay, everyone has to use that specific version of React or that specific version of Angular, definitely you can do that. In our case, we wanted to provide a bit of flexibility. What brought us this approach was, for instance, when there was the React hooks that were out, the landing page team decided to implement the alpha in production. They tried that, they learned, and then they share back with all the other teams that they didn't even know that that experiment was there, because it was completely dependent. They can take this decision. You don't have to coordinate 11 teams across different places to manage that. So you need always to understand the trade-off of your decision. The moment that you share, you need also to think about communication overhead, coordination, deployment, and so on.
Hi, sorry, I have the same question actually. So I assume you started with the single page app and then went to the micro-frontends. Was there any trade-off actually in your experience going from SPA to a front micro?
So a trade-off that we have is currently a new user is downloading multiple times React. That for us was an acceptable trade-off for several reasons. We are a streaming platform, so we expect obviously to be very fast on providing feedback to the user, but you need to have a decent connection, otherwise the video is very difficult that you are going to have that. The other thing that we have is we try to push the user from the mobile web experience to the mobile native experience, because obviously the possibility to tweak the video player for live on native is completely different from mobile browser. So for instance, iOS last year released low latency HLS. We implemented straight away. We were one of the first companies that did that, and something that you cannot have in other places. So there were, let's say in our context, the trade-off were, yes, a bit of downloading slightly more kilobytes, but the reality is providing for the user, because the other nice thing is, what we discover is when a user is in, it's very unlikely that he's signing out. They remain inside that area, and therefore we have a huge plus there, because the moment that you load our authenticated area, that is a single page application, you never download the SDK for credit card, you never download the logic for the regex for checking some certain fields, because you don't have it. So in reality is, yes, the first, let's say, subscription phase, that it takes slightly more, but then after that, it's very smooth, because at the end, the user is downloading only the experience that is needed to perform, either my account or the authenticated area or help, but always in a single way. Because you see that they download, for instance, on TV, we have an amazing impact. The first few tests that we have done, we saw that there was a drop of the startup of the application half of the time, in particular low-end devices. And that was, for me, a big success, because yes, the first time it would take slightly longer, but considering the other parts are not that big, so it's not, let's say, that could take too long. But when you are in, you have a really nice experience. And that, for me, was one of the key drivers for this.
Luca, are you doing an AMA?
Sorry?
Are you doing an AMA?
No. AME.
Yeah.
Yeah.
What time? Do you know when?
Oh, sorry. I thought the AME.
Ask me anything.
No, I did yesterday.
Oh, you did yesterday.
Yeah,
Okay.
sorry.
All right. Well, he'll be around if you have any more
Yes,
questions.
absolutely.
The next talk in this track will be at 2:55. Thomas Graff talking about Linux kernel eBPF. One more round of applause. Thank you, Luca.
Thanks.